Welcome myself, Mr. Bulaki Babashok, रयत शिक्षण संस्था आबासाहेब मराठी Arts and New Commerce Science College, Rajapur. Today's lecture we are going to discuss the new chapters synthesis of organic compounds. Synthesis of organic compounds. We have see the organic synthesis is the process of designing a molecule which may be a natural or synthetic product using the basic principles we have used to synthesize of organic compounds by using various target molecules. The reactions may involve a single step or multi-step type of reactions, but some criteria can be designed for an ideal synthesis of organic reactions. The firstly, you know that to design organic synthesis, the certain criteria can be involved. It's considered the out of the many synthetic routes are available for a given synthesis, but the best route can be chosen, which is almost fulfill the most of the requirement. Having this requirement, we have see the starting material. The starting material, it should be readily available, accordingly a low cost, means that this material will be required for these reactions. It should be it having the low cost. Next criteria, it should be number of steps. You know that in ideal synthesis it should have having the least number of steps for greater efficiency and greater yield. Hence, it should be noted that the overall yield of the process is the mechanical product of yields of individual steps. Hence, with increase a number of steps, yield should be decreases, and therefore most of the ideal synthesis it having a single step of reactions is more preferable. Hence, therefore, the number of steps involved which is least number. Next criteria, we have see the cost effectiveness. Cost effectiveness which are very important because the synthetic procedure should be cost effective with respect to the chemical substances used and operational the procedure which is easily. So cost effectiveness also it is very important due to the customers. Next point, byproducts. Byproducts which are very important, which affect the environment as well as humankind, and therefore these byproducts which are very leastly available in these various types of reactions. Hence, an ideal synthesis, the route should be far as possible to eliminate or decrease the formation of byproducts as well as the waste. They should be decreased and yield of the process also increase. Also, one of the points are very important to given, like disposal of the unused waste products will cause the environment pollutions, and therefore such types of synthetic route will be chosen as the minimize the byproducts. Next point, we have see the calculation the yield. You know that we have calculate the yield in percentage, like the amount of starting materials are converted into the final products are determined in terms of the yield of that reactions, which are expressed in terms of the percentage yield. By formula, are calculate this percentage yield is equal to the actual yield of the product means that the practical yield which is found in final products upon the expected yield of the products means that theoretical yield into 100. This theoretical yield calculated as like if we have this is the X mole of the reactants will produce X, Y mole of Y, then theoretical yield will be calculated as the molecular weight of Y upon molecular weight of these reactants into the weight of the we have take. For example, if X is a reactant, Y is a product, the 2.1 gram of this X is given, this 100 gram of this molecular weight of reactants and 50 gram of this product will be formed. We have take the weight as 2.3 like this. So we can calculate the theoretical yield by using this formula. Then we have see the very rarely the yield of the organic reactions will be 100% and practical yield generally less than that of the theoretical yield. But also we know that the many organic reactions can be generated by products and which get incorporated into the yield. Hence, therefore, the synthesis of given the 100% yield, it cannot be considered as the efficient synthesis. Therefore, the percentage of the conversion we can calculate in another term like the yield of the percentage of yield conversion. Hence, the conversion of this percentage is equal to the weight of reactants minus the weight of reactants consumed upon the weight of reactants into 100. And therefore, this formula we have used how much percentage of the conversion can take place in the reaction we can calculate by using this formula. So how much amount of the reactants are taken and how much amount of reactants are consumed upon the how much amount of reactants are taken into 100. So this formula are used for the calculate the how much amount of the conversion of reactants are take place and given the products in the reaction. Next point, we are going to the concept of selectivity. Two types of selectivity we have seen in the chapters. First selectivity is a chemoselectivity. The selectivity of chemical reactions are measured in terms of the selectivity. Firstly, the efficiency of chemical reactions can be measured, which is the ratio of desired product formed to the amount of desired product is expected, which is the two types. First one is a chemoselectivity and second type is a residue selectivity. So we are going to first point is a chemoselectivity. Chemoselectivity, which is exhibit only particular functional groups react in preference over the other functional group in the reactant. Such a type of reactions is called as the chemoselectivity. Particular functional group, if the reactants having a two functional group, one of the functional group is preferably reacts, such a reaction is called as a chemoselective reactions. For example, these reactions is a M-dinitrobenzenes are reduction by using this sodium sulfide. What happens? The two functional group are theirs, that is one of the nitro group, another nitro group. but one of this nitro group only reacts and to convert is NH2, another NO2 group which is remain, and therefore this reaction is called as a chemoselective reactions. Why it is a chemoselective? Because only one nitro group it can be reacts. See here, this nitro group will be remain as it is, but only this amino group, this nitro group which are unaffected, this nitro group which is selectively reduced to convert the amino group, and hence such a type of reactions are called as the chemoselective reactions. Hence, chemoselectively leads to desired product. In absence of chemoselectivity, the both nitro group will be reduced, resulting the undesired products like M-phenylenediamine. If such a type of reactions cannot be done in unchemoselectivity, the both nitro group can be converted into amino groups. The reduction of crotonaldehyde. You know that crotonaldehyde? The crotonaldehyde, it is also such a type of examples we can get reduced by using lithium aluminum hydride. The lithium aluminum hydride argues the transcrotonal alcohol only because the lithium aluminum hydride it only reduces the aldehyde group but does not affect the carbon-carbon double bond which having the nonpolar functional group. So such a type of reactions also called as the chemoselective reactions. Now we have see another example is a residue selectivity. Residue selectivity means that when a particular site of reactants undergo a reaction in preference to similar other site, there is called as residue selectivity in the reactions. Means that if a reactant having the two site, this is the one site and this is the other side, those two side, but one of the site gives the major product or which is the preferentially react, this site is called as the residue selectivity. Another words means that if the reagents react at one of the site is preferably, this is called as residue selective reactions. For example, Marconi's addition reaction. You know that Marconi's addition reaction, the most electronegative atom which is attached to the less number of hydrogen atom gives a major products. See here, this H plus Br minus. So Br minus is attached to the less number of this hydrogen. It is a one of the hydrogen, it is two hydrogens. So negatively charged atom is attached to the less number of hydrogens. So addition reaction due to residue selectivity, 80% of the 2-bromopropane, this is a 80% 2-bromopropane and other isomer without residue selectivity if possible to give a 1-bromopropane as the product. So this site is preferably reacts the bromine and to gives residue selective reactions. Therefore, due to residue selectivity, the isomer would be formed equally, hence yield of the desired product will be reduced due to formation of these byproduct. And therefore, the byproducts which is more, that time what happens? The yield of the product will be less. And hence byproducts which is important for the reactor.